Thank you. And so, I'm Eric Ponto. I do work at Principal. They put me in the Meredith room for some reason. That's okay. I'm going to be switching back and forth between my slides and doing live coding today. But all the code that I'm going to write is on the slides. So I have the URL for the slides. I'll tweet it out after. It's also on the last slide if you want to catch it then. The other thing is I'm live coding. I will for sure make mistakes. If you see it, shout it out, help me out. That would be great. If we can't figure it out together, we'll just switch back to the slides and see what the code is. So, all right, let's get started. So I was talking to one of my coworkers the other day, David. We've been prepping for this talk. We were talking about PHP, and he likened it as the English of programming languages, and I thought that was pretty funny. We started thinking about it more and kind of joking about it, and said PHP is like English because it borrows things from other languages. And so one example with PHP would be generators. They borrowed that syntax from Python. Another one that I like is the spaceship operator, which is my favoritely named operator. That was borrowed from Perl. English borrows everything from another language, right? The other thing with PHP is that as it's borrowed these things, it's applied those rules very inconsistently. And so we'll see later when we're looking at some of the array functions that some of the array functions take the array as the first parameter, some take it as the last parameter, some mutate the array, some don't. You kind of just have to learn that. Same way that you have to learn weird things in English like the plural of goose or moose. And then lastly, PHP has a lot of ways to say the same thing. You can solve the same problem in many different ways. Same with English, right? And this last bullet point, I think, is what makes PHP a fun language. You can be like Drupal and go all in on object-oriented, write classes for everything, or you can solve the same problems but more in a more functional style of programming. And so that's what we're going to explore today. So the first example we're going to look at is being lazy, which I think is something we all like to do, right? So we're going to switch over to my code here and take a look at this example. We have a function that I've called expensive calc. Hold on, it's not reset to its starting spot. And let's pretend expensive calc does something more than just print called. It does a whole lot of calculations. It's doing some real number crunching, and then it's finally going to return a result. When we call expensive calc later in our code, down in this conditional, my question is for everyone. I'm going to do a little quiz, show of hands. How many people say expensive calc gets called at this point? Anybody? Nobody. So I assume everyone then thinks expensive calc doesn't get called, and we can verify that really quick. So let's run that down here on my terminal, lazy PHP, and we can see, in fact, called was never printed, so it wasn't called. Does anyone want to shout out the reason why it wasn't?
X is false.
Right, X is false, and so expensive calc isn't called because of short-circuiting. So the AND operator in PHP, like many other languages, will evaluate the left-hand side of the expression first. If that's false, there's no way the whole expression can be true, so it never evaluates the second half. And so expensive calc is not called. If we make a slight change to our program, though, and take expensive calc out and store it in a variable, now what's going to happen? When we call, or when we execute this again, we see that expensive calc is called. And even though y is never used anywhere in this code, it's dead code, PHP doesn't know to not call expensive calc. And to understand why that is, we need to look at a concept of pure functions. So all of the terminology in here and the definitions I just grabbed off of Wikipedia, but we'll explain them a little bit more. So this is from Wikipedia. Pure function has these following two properties. One, its return value is the same if its arguments are the same. So that means every time you call that function, if the inputs you pass into that function are the same, the output is going to be the same. The second property that a pure function must follow is that it doesn't have any side effects. So side effect is really that your function is doing something outside of its scope. So we'll take a look at what that means in a second. But just for your mental model, a pure function is like the functions that you learned about in algebra or in your high school math classes, like y equals f of x. All right, for any given x, you have a y, and for that x, you'll always get that y. All right, so let's look at some example of impure functions that you can do in PHP. So this first one here violates our first rule, where if we were to call global scope, it's dependent on this global variable x. So every time we call global scope, we could get a different result if that global variable had changed. Here's another example that violates the first rule. By using the static keyword, count is now kind of locked in. So when we call this function over and over again, we'll get a different return value because count was defined as a static variable. Here's an example that violates the second rule where we have a side effect. The side effect here is that we're writing to a file. We're appending the word hello to a file. And finally, here's another example of where we have a side effect. We've passed in this array by reference, and so we're actually modifying the array that's outside of this function's scope. So flipping back to this example here, the reason that PHP is running expensive calc right here is that it doesn't know if this is a pure and impure function, so it has to assume that it's impure and that it might be doing something other than setting its value to y. So even though y is never used, it could be doing something else, so it runs. So what we want to do is change our code a little bit. So again, we're not running expensive calc if x is false. So one thing that we can do is simply wrap this in an anonymous function and then call y down here. So we've now made y a function that returns the result rather than just the result itself. The reason that we're able to do that is a property of pure functions called referential transparency. And so something is referentially transparent when you have an expression that can be replaced by its evaluated value, and it means the exact same thing. And so just for easy examples to understand that, 2 plus 2 can be replaced by 4. They mean the same thing. And that's a more complicated expression. If you concatenate a string together, you can replace either of these two are the same. A little bit more complicated, an immediately invoked function could be replaced by just its return value. And finally, the one that we care about is that a pure function can be called, and it can be replaced by its return value. So add 1 plus 3, since that's a pure function, we can replace add 1 plus 3 with 4 and vice versa. So what we're doing here is we're replacing this function call with the value. They can be interchanged without any real change to our program. But what we want to do here is rather than make our y more complicated, we would still like to just call expensive calc. And so instead of having that anonymous function on our y, we're going to move it up to our expensive calc and put all of our expensive logic now within this returned anonymous function. And so because we're still making a function call down here, it will only run this inner function if x is true. And it's not in this case, so it won't be called. Now we have this function that returns a function, which is a little bit weird. The reason that we are allowed to do that in PHP is that functions are considered first class. So anywhere that we could use a value, a variable, we could also use a function. So a function can be the return value of a function. It can be passed in as a function. It can be passed in as an argument to a function, and it can be assigned to a variable. What that allows us to do is create higher order functions. So expensive calc now is a higher order function. And so the definition of that is a higher order function is a function that does at least one of these two things. It could do both. but that is takes a function as an argument or returns a function as its result. Really simple examples. Here's a function that takes a function. That's a higher order function. And then here's a function that returns a function. So that's what we have here with expensive calc. We have a function that returns a function. Now let's say we wanted to pass in a value. Our expensive calculation took some sort of parameter. And so we'll simulate that by saying our print here is now going to pass or print out an A. In order to do that, we're going to need to take an A. We'll have to pass it in down here. And then we'll need to make extra to actually see this happen. And so now it says called 7 because we passed in 7. But again, we wanted to keep our kind of condition clean and move our logic out of it. So what I'd really like to do is pass in 7 right here into the call to expensive calc initially. But when I move my variable up to the expensive calc call, and we run this code again, we're going to get an error, really a warning, that our A here is undefined. This returned function doesn't have access to its outer scope. And so the way to gain access is to use the use keyword. And so we can say, I want to use the variable A of this outer scope and lock it into the scope of this inner function. So now when we run this code, we should get called 7 again. By using the use keyword, we've now created what's called a closure with this inner function. And so every anonymous function in PHP extends from the closure class, so capital C closure. What I'm talking about here is not that class of closure, but rather the concept of closure, which is a function that is bound to an environment. So it has specific variables that are locked in, that are bound to it. And so the use keyword is what creates these. We saw that if we try to access a variable outside of its scope in an anonymous function, that doesn't work. But when we use the use keyword, we have that variable in its local scope. And the interesting thing about it is that variable's value gets locked in at the time that we've defined the function. So our greet function here is using x, which is currently set to high. If we change x to hello and call greet again, we'll still get high. That x has been locked in at high at that point. So we can use higher order functions to create closures. So here's how we could rewrite greet to take in the value that we want to lock in. So greet here we can call with hi to create a new function, a new closure called say hi, that when we call we'll say hi. And then there's the same example where we'll pass in hello, and that will be the value locked in. All right, so just trying to close off this example, we saw that instead of passing just a value, we can pass function calls into different pieces of our code, and that will allow us to evaluate that function only when we need to. PHP allows you to do short circuiting. There's other ways that you could defer the actual calculation just by passing the function instead of passing its result. All right, so now we're going to move into working with numbers. And I'm going to start, it's going to be kind of a contrived example, but let's imagine you were working one day and your boss came and said, I would like you to create a function that increments a number by 1. And of course, you can do that very easily. You create a function called add1. It's going to take a number a, and then it will return a plus 1. Don't even need to test that. We just know that's going to work. Very simple, right? Then they come back, your boss, and says, now I need one to also increment by 2. So your first instinct as a good developer is to copy and paste, and just replace the 1 here, both of the 1s with a 2. Call it a day. Then of course they're going to come back again and ask for 3 and 4 and 5 and so on. And so you maybe will copy one more time and then think back to yourself, this code's not very dry. I'm repeating myself. I'm going to use some technique we just talked about. to create something more reusable. And so we're going to use that pattern where we have a higher order function that creates a closure, and we're able to lock in the value that we want to increment by. So we're going to create a function, and we'll call it an add factory, because we're going to be creating add functions. And so that is going to take our incrementer, the value we want to increment by, and just call it b. And we're going to return a function that takes our a, and we need to use our b, and then we'll return a plus b. And now we can rewrite our add1, add2, and add3 by using our factory that creates our closure. So now add1 is going to equal our add factory. We'll pass in 1. We'll do the same for 2 and 3. So we'll just place the numbers there. And we'll actually test this out to make sure our add factory worked. So we'll add 3, do 3, and we should get 6. Oops. And we do 6. Nice. So we're feeling pretty good about ourselves, right? We used this new pattern that we learned to create a bunch of add functions, and then our boss comes back and says, I want the exact same thing for multiplication. And our instinct might be to copy this, and then just replace the word add everywhere with times. So let's do that. And then change the plus sign to multiplication, and we're good. But we know in our heart they're going to come back and say, I want the same thing for subtraction and division. So let's see if we can create a generic way to create our factories. So what I want to first do is move these two right next to each other so we can take a look at both of them and look at their difference. And really the only difference is that on the top one we're adding, and the bottom one we're multiplying. And so what we can do instead of having these hard-coded into two separate things is we can abstract that out and pass in the operation that we want to execute. So let's first create functions for both. We'll create an add function that'll take our a and our b and add them together. And then we'll create our times function that also takes an a and a b, and multiplies them. And now we'll get rid of our specific add and times factories. Okay. And create, instead we'll call it a generic factory. And that is going to take the operation that we want to perform as a function. It'll still take in our b. We'll return a function that takes in our a. And a. We need to use both the function and the b, and we'll return a call to our function with a and b. And now we can change all of our add factories to use a generic factory with our add function. And the same things for our times factory is our generic factory with the times function. Our generic factory that we created is an example of using partial application. So let's look at the definition here of partial application. So it refers to the process of fixing a number of arguments to a function, then producing another function of smaller arity. And arity means the number of arguments that it takes. So what we're doing with partial application, we take an original function, we are locking in one or more of the arguments to that function, returning a new function that takes the rest of the arguments that when called, we'll call the original function then with all the arguments. What that looks like written out, with our generic factory, we're only taking in one argument. Here's an example of how you could write a function that would work for any number of arguments. So here we're using the splat operator to take in any number of arguments and storing those off in an array. Then we'll return a function that again takes any number of arguments and it stores those off. And then we're able to merge both sets of arguments together and pass those into our original function. So that would work with our add function to create an add1. but it also work with a function that takes in more than 2 parameters. This one takes in 3, and so we can use partial full name and pass in Eric, which would only lock in the first name variable. So if we were to call Eric's only, we'd then pass in the middle and the last name. We could also create a function Eric M's only, where we've locked in both Eric and M as the first 2 arguments. So if we call this, we would only be passing in the last name. So we could go back to our code, get rid of generic factory everywhere, and we can change all these references to partial. And just to prove that it works, let's print out times 3 with 3, and we should get 9. Nice. All right. So now that we've created these different functions, the increment and multiply, let's use them together in some way. So let's say now we want to take a number, add 1 to it, and then multiply it by 2. So we'll start off with a number, x equals 2. We'll create a temporary variable, y, that does add 1. Then we'll have another variable z that's the result of times 2 of y. Then we can print z. So let's go ahead and do that. And we get 6, right? 2 plus 1 is 3 times 2 is 6. So this looks a little ugly, right? We've created these temporary variables that we didn't really need. So we can move the call of add 1 into there, get rid of our y, and this will run exactly the same. But this solution isn't very reusable, right? We can only call it the one time with our x. So if we wanted to create a function that does both times 2 and add 1, we need to write that a little bit differently. So let's try to do that. Function, add 1, then times 2. That'll take an x, and we want to return basically what we just had, right? Times 2, add 1 of x. And let's actually try to run this code. And we'll see that we get, we need to actually call the function. We'll see that we get a bunch of errors about not knowing what these variables are. And again, that's because these variables were defined outside of the scope of this function, so we can't access them. So if we try to do a use here, that also doesn't work because use can only be used on anonymous functions, on our closures. So we need to define this as a variable instead and call it like this. And so that will work now, but I don't know that this is any better. It looks uglier, I think. And so what we're going to do then is turn to classes to hopefully provide us a better interface. So I know it's like blasphemy to use classes. We're talking about functional programming. But we're going to use a class that's going to help provide us a better interface for working with functions and our values. So the class that we're going to create is going to be a box. And it's going to do what it sounds like. It's going to provide a box around a value. So we're going to create a private value, x. And we're actually going to create a private constructor that will only be called from inside itself, right? A private constructor, so we can't ever call new box. Still, this is functional programming. We don't ever want to instantiate a new class ourselves. We're going to want a function that we're able to call to do that. So we'll create a public static function called of, because what we want to do is create a box of a specific value. And here's where we can call, where we'll actually call new, but we've abstracted that away from the user of our class. They don't ever need to call new. They'll interface with this via of. We'll need a way to unbox our value to get it back out of the box, and so we could create a function called unbox. But instead, we'll use like a PHP trick and use invoke. So we'll be able to just put 2 parentheses on the end of our box, and that'll spit the value back out. And so here we'll return the actual value. Now this box doesn't do anything yet, right? We're just storing a value and then being able to get it back out. And so the way that we're going to be able to interface with our value is we're going to create a function called map that will allow us to pass in a function and have that function applied to our value. So let's create that. Map, it's going to take a function, and we're going to return a new box where we have called that function with our x. So this is giving us an interface to apply a function to a value, and then return a new box, and then we can get the value out of the box. So let's go ahead and use that here. We'll wipe out what we did down here and instead use our box. So we'll say box of 2, and then we can map with a function. And so we'll use our add 1 then times 2. And then to get the value out, we have to invoke it. So there's the little trick, and we can run this code. Let's go look at our box. Where is it run? Right there. And we can run that again. And we shouldn't get 4 this time, we get 6. Right, good. The interesting thing about this map method is it has an associative property where we can, instead of composing our functions together like we did, we can chain them. And so I'm not going to go into, I've been doing some functional programming terminology, won't get into the really deep stuff, but our box is considered a functor, so if you want to look that up in your own time, you can. But functors have this property with maps that instead of having to compose the functions first, you can just chain your maps together. And so we're left with this really nice interface for our box where we can really explicitly say what's happening to our value as we pass it through these functions. So we start off with a box of 2, then we're going to add 1 to it, then we're going to multiply it by 2. And it reads almost like English, even though there's some weird symbols in there to someone who isn't a programmer, they could maybe still figure out what's going on with this code. All right, let's move on. So we went over single values, our numbers, and now we're going to deal with arrays. So we have a list of numbers instead. All right, for this exercise, what we're going to do is we have an array, 1 through 5, and this is kind of a classic functional programming example. We're going to find the sum of the odd squares. So we're going to get the squares of every value in our array, take just the odd ones and add them together. And so how we would probably first start off trying to do this is writing a for loop. And when writing a for loop, I always have to pause twice. The first time is to remember, is it less than or equals to? It's less than. Then the other is to figure out, how do I get the length of my array? Now in a lot of other languages, it's either length or size. In PHP, it's count. And then the inside of our array, we'll kind of do those 3 things that we talked about. We're going to get the square of our value. So we'll just call that square. That'll be equal to our array at index I, and we will square it. Then we'll check if it's odd by using the mod operator. So an even number mod 2 is 0, so that'll be false, and an odd number mod 2 is 1, so that'll be true. Then if it is true, then we will take our total and we'll say total plus square. All right, let's print out our total down here, and we'll see what we get. And it's 35. We can check the math really quick. If we square, we'll have 1, 4, 9, 16, 25. The odds are 1, 9, 25. 1 plus 9 is 10, plus 25 is 35. So our code worked. In order to read this code, though, we kind of have to step through it line by line. It's very imperative style of coding, right? We saw in our box example with our numbers, we want a more declarative style where we can just kind of read through, skim, and almost read in English to figure out what's going on with our code. Well, we can take a first stab at this by applying some functions. So I've actually already written out the functions that I want to use. And so I have a square function, it's going to square a value. An is_odd function that will take a value and tell us if it's odd or not. And then finally an add function that will add two numbers together. So we can go back to our example and start replacing some of our operations with these function calls. So let's do that. And then here we'll say is_odd of square. And then down here we can add total and square together. And we haven't really made much improvement to our code, but it's a little bit of improvement. We've replaced all of our operators with English words that we can read to understand what's going on. But we still kind of have the problem of this for loop that was a little bit tricky to remember how to write. We still have two temporary variables, this square variable and this total variable. So let's see if there's any array methods or array functions in PHP that can help us. And of course there are, because there is a ton of array functions in PHP. And I already kind of mentioned that they're implemented a little bit inconsistently. Sometimes their names are kind of strange. Key exists, I don't know how you know that, is an array function where all the other ones start with array. So instead of trying to look at all of these, we're just going to focus on three: array map, array filter, and array reduce. So all these examples are going to use that array that we already saw and those functions that we looked at as well. So array map allows us to transform an array into another array by applying a function to each item in that array. So what that looks like with array map, it takes a function that we want to apply in an array. Note the array is the second argument. And it will call every value in that array. It'll call the function for every value in that array. And so with our array 1 through 5, if we square every value, we'll get 1, 4, 9, 16, 25. Just to diagram that out, to help see visually what's going on, each value gets passed down through our square function and then written out on the other side. Filter works sort of similarly, where we're able to apply a function to every value in our array. But the difference is it is only going to get a subset of our array rather than the whole, because the function that we pass in will be a predicate. So a predicate's a function that returns either true or false. If it returns true, we're going to keep the value. If it returns false, it'll get discarded. So if we call array filter on our array, which is now the first argument, and use is_odd, then we'll get only the odd values back, so we'll get 1, 3, and 5. Just for another diagram of how that works, each of our values gets filtered through is_odd. If it passes, then we keep them. Otherwise, we don't. All right, array reduce. So this is the most complicated one to understand, so we'll talk about it just a little bit longer. But the idea behind reduce is that it will reduce all of the values in your array down to a single value. And that value could be in another array, it could be a number, it could be a string, a boolean, it could really be anything. But it's the idea that all the values become one in some way. So in some other programming languages, reduce is called fold. So that's another way you can kind of think of it. We're folding all the values on top of one another to produce a new value. So array reduce the signature takes an array, and then it takes a reducer function, and then it takes a seed value. The key thing to understand with reduce is the reducer function. So a reducer function takes two params, unlike the other array methods that we're just taking the current item, this one has an accumulator param and the current item. The accumulator param, the first iteration through the array, is going to be equal to your seed value, but every subsequent iteration, the accumulator is going to equal the previous iteration's return. And so the best way to understand this is really to look at an illustration of it. And so I've shortened it to just 1, 2, and 3 for simplicity. But let's look what would happen if we're reducing this array 1, 2, 3 with an add reducing function. So the first time through, our accumulator is going to be 0, which is the seed value that we passed in. And our current value is 1. We pull that down. We're going to add those two together to get 1. That 1 becomes our accumulator. So in our next iteration, we have 1 plus our current value of 2, which is 3. 3 becomes the accumulator. 3 is also the current value. We add those together, get 6. We're done iterating, so we get 6. So now let's go back to our code, and we're going to apply map, filter, and reduce to do the same calculation that we were doing. So first, we're going to get all of our squares by using our map. Oh, we have to pass in the square first, then the array. Then we'll get just the odds by using filter on the squares with isOdd. And finally, we can get the total by using reduce on our odds with our add function and seed it with 0. So if we run this code again, we should still get 35. And so, again, we have these temporary variables, and we might want to try something like pass the array down here, then we could pass this line into reduce. Then you get this one long chained function call, and it actually ends up looking worse. So instead what we want to do is try to combine all these function calls into another function. And that is called array composition, or not, function composition. Actually, I skipped over that way long ago, so let's just take a quick look at that definition. But function composition is the process of combining 2 or more functions to produce a new function. And if you remember, again from math class, here we are composing G and F, which are functions, into a new function that's equivalent of calling f of x and then passing that value into g. So g of f of x. So we can do that same thing with the functions that we're writing now. And we're going to do that using our reduce again and do something called pipe. So we're getting there. Pipe. Okay. As I mentioned earlier, functions are first class, so they can be used anywhere any other values can be used. So what we're going to actually do is have an array of functions, and then that will allow us to call reduce on that array of functions. So what the pipe function does is it takes a list of functions, creates an array. We're going to return another function that takes a value, and we're going to use that array of functions. And then finally, we'll reduce on our array of functions. We'll use the value that you pass in as the seed value. And then our reducer function then takes the accumulator, the current function in the array, and calls that function with the accumulator. Again, it's easier to see what's going on when you look at a diagram. So let's set up what we want to look at in the diagram. We have some simple functions here. Add 3 times 2 and square. If we pipe them all together to create this new function calc, when we call it with 2, 2 will get piped into add 3, and then that result will get piped into times 2, and then that will get piped into square. So in the diagram, this looks just like our reduce diagram, because pipe is just reducing on an array of functions. We see 2 is our accumulator, add 3 would be our current item, We run that to get 5, that becomes our accumulator, and so on all the way down until we get our final result of 100. And so we can go back to our code here and try to use pipe to get these 3 functions to work together. So now let's create a calc function, and we're going to pipe together these 3 calls. So we'll do array map with our square, and then we'll do an array filter with our is odd, and finally we'll do an array reduce with our add and our seed value. Now this won't work, right, because somehow we need to pass in the array to each of these, and actually the position of the array that we pass in is different. We did see with partial that we were able to lock in a value. So we are able to lock in these functions, but when we looked at partial before, it was only locking in our leftmost arguments. On filter and reduce, we want to lock in our right arguments. So I actually have a utility for that, partial right. It looks just like partial, except for when we merge our arguments down in this return call, the original arguments that you locked in are passed in on the right side. So if we go back here, we can make both of these partial right and lock those values in. And now if we called calc on our array, we should still get 35. We'll see though. Yes, okay, awesome. Okay, so we're getting better here. We're able to see exactly how our value, our array, is flowing through this logic. We're going to square it, then just get the odds, and then add them all together. But what we want to do is, like we did with our number box, we're going to create a box for arrays. So I'm actually going to copy over our original box and modify it slightly to accept arrays. So now we'll call this array box. We'll keep our constructor the same. We're going to add a new static function called from, which is going to take an array. It's just semantics and how these sort of things get named. Where from, you say from when you have a list of things, and you say of when you have a single thing. So we'll say from. This is going to return our new array box. And now of, we'll keep it for fun and call it, it'll call from, but we'll box it in an array. The bigger changes are going to happen now in map. So map is still going to take a function, but instead of applying that function to the array that's been boxed in, we're actually going to call our array or function. So let's do that here. We'll say array map. We'll pass in the function, and then we'll pass in our array. We'll do the same thing for filter and reduce, so we'll just copy and paste those. We'll change this to filter. And we have to change the order here. And then for reduce, we also need a seed value. And we change the order here again. Okay, then we're able to go back to our array example. We can get rid of our calc and use our array box instead. So our array box from our original array. Then we'll map using our square function. We'll filter using our isOdd function, and we'll reduce using our add function and seed the value as 0. So if we did that all correctly, we should still get 35. And we do. Good. Okay. So the examples up to this point were kind of abstract. Things you would do with numbers, things you would do with simple arrays where you may not need to go all out and create these more complicated structures, or really need to follow the strict functional programming rules. So I want to end with an example that's a little bit more practical, where we're going to be creating an interface for writing to a file, where we're still going to create a class. We're still going to use some functional programming principles, but be a little bit more practical about it. So we're going to create a class called FileWriter, and it's going to have a private file. And to write to a file, we need to open it by its name. We need to actually write some text to it, and then we need to remember to close it, which we don't always remember to do. But let's create methods for all of those things. So we'll say set file. That's going to take the file name, and we'll set our file equal to fopen. We'll open it with the file name, and we'll open it in write mode because we want to write to it. Create another function that will set the text of the file. So that will take a string of the text, and then we will do an fwrite on our file with the text. And finally, we'll create a public function to close the file. And we'll do an fclose on our file. Okay. So this is kind of the standard, like, object-oriented way that we would create a class to do this. So down here in our code, let's actually create a new file writer. We're going to consume it now to actually create a new file. So we need to set the file. We'll just call it test.txt. We need to set the text in it. We'll just do a hello world. And finally, we need to remember to close it so that we don't leave the file open the whole time our program is running. So we can go down and actually execute this. And we'll see that there's test.txt. And if I test.txt, if I write that out, it says hello world. Nice. Few issues with the file writer API as we have it right now. One, we're calling new, which we said we don't like to do. We will always want to call functions. Two, we had to reference the instance of it a bunch of times to pipe all these things together. And then finally, we had to remember to close it. Oh, and really, there's one other thing is that after you close it, it's not clear whether or not you should reuse your F or not. Could I write another file with the same file writer? All of those questions are kind of not answered by this implementation. So what we're going to do is change it just slightly to help alleviate those things. So we're going to create a static function called write, and that's going to take a callback function. And now instead of the consumer having to create a new file writer, we're going to do it ourselves within the file writer and pass that to the callback function. So we'll say new static. Now the user of this write function can do whatever it wants with that file, pass it back to us, and then we will close it, so they don't need to remember to do that. And we can even make this private. The other thing that we want to do is make it so that you don't have to keep referencing the file over and over again. We do that with a simple trick to return this from our methods. And so this is similar to how we were returning like a box of every time in our box examples. This we're not going to create a new instance of our file writer every time. We'll just return the same instance, which will make it a little bit nicer to use. So now we'll have our file writer, and we'll call write with a callback function, and we'll get our instance of the file writer from into our callback. And now we're able to do our operations inside of that callback function, and we've solved really all four of the problems that we had. We no longer have to call a new file. We no longer have to reference our instance over and over. or we can chain it together, and we don't have to remember if to close the file or need to worry about if we can reuse the instance or not. So just by passing a function instead of like creating a new instance ourselves, we've made this code a lot more readable and clean. And so I end with that example of just how we can use some of the things that we talked about today to make something sort of practical have a better interface. So that's all. Thank you. I think that was 15 minutes, so I still have like 10 minutes for questions if people have any.
Are there PHP packages that support functional programming?
Yes, there are for sure. Yeah, so I would not recommend like creating your own array box or anything. I think Laravel has a collections class that gives you a bunch of different methods that you can do on arrays. There's definitely a lot of packages out there too for some of the utility functions like the pipe or partial, where you're able to manipulate and change functions. Yeah. Okay. Thank you.